Hello again. We are continuing our discussion on quadratic functions, and today we're going to talk about axes-intercepts, where that quadratic function would cross either the x-axis or the y-axis or both. This is lesson 10.2, so let's get started. The y-intercept is where this quadratic function is going to pass through the y-axis. Every quadratic function has exactly one of those. And here's how we find it. We're going to set every x equal to 0 so that y is the only variable we have, and we will solve for that value of y. So if I have y equals x squared plus 4x minus 21, I'm going to replace every x with a 0 so that my equation reads y equals 0 squared, which is nothing, plus 4 times 0, which is nothing, minus 21, which is negative 21. So this graph is going to cross the y-axis at negative 21 on the y-axis. To do the x-intercepts, every quadratic function could have two of these. It could have one, or it could have none. So in order to find them, what I do is I actually graph this on a calculator. It's a little bit trickier. So I have y equals x squared minus 2x minus 15. So if I graph that, here's what it looks like on the calculator, and I've used the solver on the calculator to figure out where those zeros or roots or x-intercepts are, depending on your terminology that your calculator uses. Most calculators use roots or zeros. And as you can see by the little pink crosses there and the numbers in the bottom left corner of each screen, you can see that one of the x-intercepts is negative 3 and the other one is 5. So that means that the x-intercepts are x equals negative 3 and x equals negative 5. So keeping that in mind, what I can do is I can rewrite this quadratic function in root form and say that y is equal to x minus one of the roots, which is negative 3. And of course I can write x minus negative 3 as x plus 3. Multiply that by x minus the other root, which is 5, so I have x minus 5. So this is just another way of writing the same quadratic function. It's just written in root form so that I can actually see where the x-intercepts are going to be. So that is axes-intercepts for quadratics, kind of in a nutshell there. If you have any questions, please let me know, and I will see you tomorrow.